I'm so tired right now. Where's my pen? Okay. This is I don't know. This is X, I guess. And then what? You don't even have to do it this way. You can just use the computational method for this. That's what they do. I don't have to do all this. So for the computational method, if you forgot, that is ignore this. You have X here. All the values of you can just do X squared minus the sum of the X values squared over n over n minus 1, because this is a sample. I think. Yeah. And then just plug and chug. So for this, table formula will look like X squared etc. Then the sum is 344. So you do this down. I'll just do it. This is a 6. 1936, 2116, 2500, 2916. And then you add all these, which is 15,192. So for this formula, you have 15,192 minus the sum, which is 344, squared over n, which is 8, over n minus 1, which is 7. And this gives you, 1 second, this gives you 57.143, which is the variance, and then the square root of the variance, remember, is the standard deviation, which is 7.56, and there's your answer. And then fill everything out accordingly. You have the mean. These are the deviation scores you calculate. Right. Should I do I'll do the deviation score to actual values. This is not the median, this is not the IQR. Okay. So not deviation score, but percentile location, it's 4.5. So you go to the fourth data point, 1, 2, 3, 4, 42. And then the 0.5 means halfway the distance between this and the next data point. So luckily here the distance is 2. So halfway between that is 1. So this is 43. For this, for Q3, it's 6.75, so you go to the sixth data point, 1, 2, 3, 4, 5, 6, 46, and then 3/4 of the way between this and the next number, so that would be 49. Sorry, I'll write it over here. Q3 equals 49. And then this is, Q1 is, location is 2.25. You go 1, 2, and then 1/4. And here we're gonna have to do the math. So the distance between this is 42 minus 36 is 6. And then you multiply 6 by the remainder, so 6 times 0.25 is that like 1.25 or something? 1.5, sorry. 1.5. So you add 1.5 to the second value, so that would be 36 plus 1.5, which is 38.5. And then Q3 is 49, this is this, so IQR equals Q3 minus Q1, which is 49 minus 38.5, which is 10.5, if I'm not mistaken. And then the mode is just most data points, interquartile range, boom. Standard deviation is this. Nigeria's percentile rank. How you do this is with this formula right here. So it is the third, even though it's the same, we'll call it the third because it's the third on the list. So the percentile location is 3. Can I write it? Okay, you can see here if I write it here. So, and just plug into the formula. 3 equals P, this is what we're looking for, the percentile rank, over 100 times n plus 1, n is 8. 8 plus 1, which is 3 equals P over 100 times 9. Divide by 3 on both sides, or divide by 9 on both sides. 0.333 equals P over 100, then multiply through by 100 to cancel this out. So you get 33.3 equals the percentile. So it's the 30, Nigeria's at the 33rd percentile. Coefficient of variation is just, it's on your formula sheet. It's standard deviation over mean. Okay, standard deviation 7.56 over the mean is 43. And what is that? 0.1758, which means it's the 17.5, or 17.5% is the coefficient of variation. And then, would it be reasonable for the skewness to equal to 1.5? Remember, normal skewness value is 0. Anything above that is positive. Anything below that is negative, obviously. Well, let's look at the measures of center. This is the mean, right? The mode is 42, and the median is, let's count towards the center. So 30 and 54, 36 and 50, 42 and 46, 42 and 44. So the median would be in between these, which is 43. I'll just write that down. Oh, it's right here, sorry. Median's 43, which is the same as the mean. So the skewness could not equal 1.5, most likely. Awesome. And then 36 is just algebra, pretty much, PEMDAS. and we need to do a frequency table problem. We can do 37 or 38. Let's do 37. We'll probably get something more like that on the test. Can you page over? So, for any frequency table where you get an x value and then a frequency for those multiple x values and a frequency corresponding with those x values, you want to set it up like this every time. This is the most important part of the test. It should be muscle memory. You have x. This is your number of whatever. It's also your event, is what you might call it. Okay. F is the frequency of that happening. F of x is the relative frequency, and this is the same as P of x, which is the probability, or F over n. These are F of x, F over n, P of x, these are all equivalent. And then you can have a column for your mean. Let's do that just to make it easier. So mu, this is your mean, aka your expected value. And then you have the distance from the mean squared, and distance from the mean squared times f of x. Because if you look on your formula sheet, the variance formula for a discrete random variable is this. Sigma squared equals sum of x minus the mean squared times f of x. So you do this and this to get this. Basically, you do all of this to get this because, oh, I forgot, x f of x. This is your relative frequency. The x f of x column is the expected value, is like the relative or like EV, let's say, for each event or something. You don't have to worry, that might not be the right name, you don't have to worry too much about that. But let's go on with the table. You have 0, 1, 2, 3. The number of days you get these events are 5, 15, 10, and 0. And then you proceed with the table. You must know to build the table like this. You can look at your formula sheet. It gives you all this, which is pretty much all you need to build it. You need to remember from the frequency you want the relative frequency, you want that x times f of x. Just remember x times f of x. That's the most important column because all the others are relatively self-explanatory. You gotta remember all the ones with the mean. It's in the formula right here. Remember this. So the total is 5 plus 15 plus 10 is 30. For this, you just do 5 over 30, 0.167, 15 over 30, 0.5, 10 over 30, 0.333, 0 over 30, 0. X times f of x, x times f of x, 0 times this, 0. Sorry, let me divide like this. Okay. 0 times anything is 0, 1 times 0.5 is 0.5, 2 times 0.333 is 0.666, 3 times 0 is 0, and then you add these for the expected value, which is 1.166. This is your mean. This is the expected value of checks in a given day, the sum of these. If you look at your expected value formula, it is the sum of x times f of x. This is the x times f of x column. The sum is this, is your mean. Let's just write it here. 1.166, 1.166, 1.166, 1.166. And then x minus the mean. 0 minus this is just going to be negative. 1 minus that is going to be negative 0.166. 2 times that is positive 0.834. Then add 1 is 1.834. Awesome. Next column, you square all these. You get, where is this? Okay. You get approximately, so you're only supposed to round to do 2 decimal places here. So you get approximately 1.35, 0.03, 0.71, and 3.39. And then you just multiply this by f of x. As you know, I mean, you see it right here, guys. This times this. This times this is approximately 0.23. This times this is approximately 0.01. This times this is, again, 0.23. And this times this is 0. You add these, is your variance, and that is 0.47. Remember, this is your variance. This is not your standard deviation, it's your variance. To get the standard deviation, you must square root this, so 0.47 square root is 0.69, which is your standard deviation. And you can just go on from there. This is the probability distribution right here. Remember, relative frequency is probability. 2 conditions for a probability distribution. One is that all of the values are greater than or equal to 0, so they're not negative. Sorry. Greater than or equal to 0. So they're all 0 or positive. And the second is that sum of all values equals 1. It can be like 0.99 because of rounding and stuff. But if you look, 0.167 plus 0.5 plus 0.333, it adds up to 1. So that's how you know it is a proper probability distribution. This will also very likely be on the test. Expected number of bad checks per day is your mean, which is your expected value. 1.16 is the answer they have on the answer key. And the standard deviation of the number of bad checks per day is 0.69. I advise you to, if you haven't done the other frequency table problems, do that. But you really want to familiarize yourself with making the table, having each column lined up, understanding what they mean. I hope I helped you with that. And just familiarizing yourself with all the operations, because it's fairly simple. It's just a lot of work. You can easily get lost in it or multiply the wrong thing. And then we'll just skip all the other stuff and go to 40. I'm skipping the other problems because all the frequency table problems are more or less the same. Just make the frequency table and everything else will fall into place. Okay, so here, distribution is positively skewed. The mean is 75 and the standard deviation is 5. Okay? This is the same as the sigma symbol, except you're supposed to use this for samples and this for populations, but they're basically interchangeable in class. So it's positively skewed, which means that there are values that skew the mean to the right. So it would look something like this, where the median would probably be here. The mode is here, obviously, but the median is also here because it's the middlemost value. You see the height is the frequency, and so the middlemost value will tend to be here. These upper outliers pull the mean this way because mean is weighted, and so the mean is somewhere around here. Okay, cool. This is 75, standard deviation of 5. So one standard deviation out is 80 and 70. This is one standard deviation. And then one more is 85 and 65. This is 2 standard deviations. And remember, this is skewed. There we go. This is skewed. This is not normal because it says right here skewed. So you cannot use the empirical formula. You have to use Chebyshev's theorem instead. Sorry, I'll write this again. So the distribution will look something like this, with this being the mean. The median and mode are both here because, as I said, the y-axis is the frequency, so this is not very frequent, this is very frequent, this is not very frequent. That's why it looks like this. This is the median, which you don't really have to worry about. You have to know that these values pull the mean to the right of the median because they are higher. As you can see, the tail on the right is much longer than the tail on the left compared to the median, which is a good measure of central tendency for skewed data. That's why you use it, because it disregards outliers. Anyways, this is 75. One standard deviation out is 5 higher and lower, so that is 80 and 70, and then 2 standard deviations is 5 more, so that's 85 and 65. This is 1 standard deviation. This is 2 standard deviations. Okay. At least what percent of the students received grades between 50 and 100? So let's just draw this out. Thankfully, 50 and 100 are, like multiples of 5, so that makes our job easy. We have 90, 95, 100. This is not exactly to scale, but, and 60, 55, and 50. This is what we're looking at. We're looking at the percentage that falls within this distribution. Let's count. This is our mean, right? Let's count how many standard deviations this is. So it is 1, 2, 3, 4, 5 to the right, and 1, 2, 3, 4, 5 to the left. So this is 5 standard deviations from the mean, that means that k equals 5, because k is the number of standard deviations from the mean. And we're using K because we're using Chebyshev's theorem because the data is skewed. So if you forget, the formula is whatever percentile or whatever percent of the data falls between here is 1 minus 1 over k squared, where k is greater than 1. So you do 1 minus 1 over 5 squared, which is 1 minus 1 over 25, which gives you 0.96. So 96% of the data fall between 50 and 100, which is 5 deviations from the mean, but it asks 50 and 100. Very good. Then we'll do B. Between what two values do at least 84% of the data fall? So instead of getting a k value, here we start with the percent of the value between whatever points, and we find the k value, and then we use that to find the points. I'll say that again. We start with the percentile that's given to us, then we have to use a little bit of math to find k, and then we use k to find the number of standard deviations from the mean. Remember, standard deviation is 5, and we just calculate the distance that would be, and then we have our interval there. So 0.84, because it's 84%. There we go. Is 1 minus 1 over k squared. Subtract 1 from both sides, you get negative 0.16 equals 0 minus 1 over k squared. You multiply by negative 1 or whatever, and just cancel out the negatives like this. 0.16 equals 1 over k squared. You multiply by k squared on both sides to get this out of the denominator because you want it in the numerator. Like so. Then you have 0.16 k squared equals, this cancels out and you just have 1. Then you divide through by 0.16 equals 1 over 0.16, which is 6.25. K squared equals 6.25. K equals root 6.25, which is 2.5. So we have our original percent, we have our k value. This means that 84% of the data falls, remember this is just the definition of the theorem, between 2.5 standard deviations of mean. We know the standard deviation is 5, the mean is 75. So to calculate the interval, I'll move this down. All we do is 2.5 times the standard deviation value is 12.5. Then we have the mean plus or minus 12.5 because it goes out to the right and to the left. And this will give you 87.5 and 62.5. These are your values. This is the low, I'll write it the other way, 62.5 and 87.5. These are the values where 84% of the data fall. Boom, so easy. I would heavily advise you just make up a percentage like 87 or 66 or something like that, and then try this whole process for yourself. And that should be it. Just review definitions, look at the slides, blah 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 blah. All right, good luck.